Hello. So we're back, and this time we have a special job, actually from a special customer. Remember this video? Probably you remember this video with the customer which came and I helped him with the soldering job. Oh, he is Mike. He's been a audio engineer for BBC, and now he sent me. Actually, he brought it here because he's living on the same town. A laptop repair. Yeah, Mike's. Not only the laptop repair, but he gave me the motherboard for spares. So we should be able to fix this laptop. My HP A40G5 doesn't take power or charge. Windows show power connected. Hmm? i7 Gen. So this is a decent laptop. So basically what he's saying, the laptop is working. Yeah, but it's not charging. He told me he charged the battery on a different laptop. So yeah, the laptop it is coming on. Now let's plug the charger because I'm curious to see what the laptop is doing. So 19 volts. We need a little bit of current. Let's see what current do we have. And we have, yeah, too low. Let's go, yeah, about there, 3.4 amps. The laptop it is working. Plug in the charger. It's taking no power at all. You see the current? Nothing. But the charging sign is there because you'll think, okay, it's a charging port issue. But the charger, it is detected. Plug in the charger, the laptop appears to charge, but it's not charging, and it's no current. I mean, nothing, zero. You can see? So it's a pretty interesting fault. Now, we know the battery is good because the customer charged it on a different laptop. So we can rule the battery out. Then what can be the problem? That's a very good question. So what do we have there? We have the input circuit. We have the BQ chip, which is managing the power input circuit and the charging. So we are spinning with the repair around this. Okay, so the laptop, it's open. Yeah, that's a nice motherboard. Ha! I mean, you can spot, like, instantly spot the power on this laptop. So you can see this is a big coil with 4 MOSFETs. Yeah. So this is the power supply which is creating the main power rail. So the main power rail most likely has the battery voltage. I didn't check, but we can check together. Let's see. So the main power rail voltage is MOSFET coil capacitor 10.4. 10.4. Why is 10.4? The battery voltage 11.5. You can't see 11.5, and the main power rail is like 10.4. Now this power supply is creating the main power rail. I'm pretty sure about that. So this is the 19 volts, the input, and the output probably is here, and it's 10.4. You can see, so it's not charging. Now why is that? Why is not charging? See, this is a good question. Let's go and check the input circuit. Yeah, just slowly try to figure it out, the schematic. No rush. It's Sunday. We had the live stream on the morning. So this is the input circuit. And the charging port probably is here, right? So yeah, that's the charging port. But what is this connected to the charging port? This one. So this must be plus, right? I mean, here is some rosin. Not sure if someone worked here. So what is this component? Must be the lead sensor, right? No, but not on this side. No. So this is connected to plus, is connected here, and is connected somewhere. Let's check together, yeah? I mean, I'm assuming is the protection on the but it's not, right? The protection on the charger ID pin. So here we have 19. Okay, so this component is taking 19 at the output. Here 0. No. Here 0 volts. Here 0.8. And here 19. Yeah, it is taking 19. I'm a little bit confused, but I want to focus on this one, right? Yeah. So let's see. The power is coming to those inductors. So from the inductors, we have, check here the schematic here. This is a resistor, and from here, the BQ chip is taking power. Yeah, the BQ chip is taking power before the MOSFET. Then we have the first MOSFET. Then on the serial mode, we have the second MOSFET. Then we have the current sensor here, and from the current sensor is going to this power supply with 4 MOSFETs with this interseal chip, which is creating the main power rail. Okay, so I want to check the first 2 MOSFETs. Let me unplug the battery. So I unplug the battery. The first MOSFET is good. Good. And the second MOSFET is good. So our problem is not like shorted MOSFETs. What this MOSFET is doing here, not sure. But let's test it. And the MOSFET is good. Those MOSFETs probably are good because we do have 19 here. I'm assuming they are good, but we can check. Good. Good. So all MOSFETs are good. Now, we don't have a BQ chip on this laptop yet. We have this interseal chip. Yeah, this laptop doesn't have a BQ chip. So this interseal is managing this power supply, which is creating the main power rail, and also the charging. But we learn a lesson on our all repairs. And the lessons we learn is if the charger ID pin is missing, then the laptop it will not charge. The problem is it is appear to charge. I mean, on the Windows we have the charging sign. So what could be the issue? Let's go on the battery. So the battery is here. Okay. So on the battery, this track is going somewhere. You know what? I think I know where this track is going. I think this track is going exactly here. Exactly here. No. No, it's not going here. Sorry. No, has to be connected on the main power rail. Okay, but you know what? I'm curious. What is the voltage of the main power rail without the battery connected? Without the battery connected, it's taking no current at all. And the voltage of the main power rail is 0. Lol. Okay, so basically this laptop is not working on the charger even without the battery. So on the input, we have, So on the input of this power supply, we have 19. But on the output here, we have 0. Yes, so no voltage at all. Now the interseal chip, let's focus on this one. Like how I said, From here it's going to the BQ chip, but it's not going to the BQ chip, it's going to the intercell chip here. Not sure on which pin. Not sure on which pin is going. But we can check on those capacitors. Here we have like 3.7. You know what? I remember I had some issue on a laptop. I work a lot on a fault with one capacitor. Yeah, here is the main power rail, and here is the you see we have 19.2 going to the intercell chip. So the intercell chip has power. Now I really want to pull the schematic datasheet of this chip. Or we should focus on the charger ID pin. I believe the charger ID pin is this one, and it's like 1.2 volts. And I'm assuming this is the output and it's 0, or this is the ground. So this is 19. This is the input, and what is this then? Let me disconnect the charger and let's check together if that's ground. This is ground? Yeah, it is ground, lol. Okay, so this is not, this is only a protection on the charger ID pin. Good. You know what? Let's take the spare board and check and compare with the spare board we have. So on the spare board, well, that's beautiful when we have actually a spare board. So on the spare board, we have same thing, right? Yeah, here you have ground. But let me plug the charger and check the voltage on the middle pin. Plug in the charger. The charger is plugged. And on the middle pin, we have 1.1. Okay, so we are assuming the input circuit is good. But I want to check the intercell chip. I mean, that 3 volts was weird. So here we have 3.7. Lol is the same. Let me see the output from this power supply. Check here, we are like 12.5. I mean, this is a broken motherboard. Yeah? Check here. So this is a broken one. You can see it's broken motherboard. But this power supply, just creating the main power rail, it's actually good. We have 12 volts. And probably if I plug the battery, it's charging, right? Plug in the battery. No. Why? 1 second. Because we had 12.5. We checked together. Why is taking no current? So the main power rail is 12.5. Huh? The battery voltage is 12.4. So why is taking no current at all? I mean, okay, the board is broken. I can understand that. But the power input circuit is working. You know what I mean? We have 12.5 there. With 12.5, should charge my battery, which had 10 volts. You remember 10.4 was. So why this battery is not charging? I mean, it's taking no current at all. Okay, this is strange. But I'm assuming the battery is good because the customer charged the battery, right? Yeah. Let me lower the voltage. Coming with the minus and plus on the battery, and the battery is taking no current. So how the customer charge this battery? But no, okay, no. Probably the battery is not getting enabled by the EC chip. No. Listen, we are going on a different direction, and it's not right. I mean, on this board, we do have 12.5 on the main power rail. On the customer board, from the laptop, we don't have. So here we have 12.6 actually. Good. And here we have nothing probably. We checked already. Here and here, and we have 0 volts, nothing. Okay, let me search for the data sheet of this chip. And we found it. Check here. So this is our chip, ISL 95338. That's the one. And this is a basic schematic. We can see here the 4 MOSFETs. We can see that big coil from here. But this chip is not charging the battery. Oh, sorry. Yeah. I mean, this laptop doesn't need a charging circuit because it's a charging circuit. I mean, the main power rail has the battery voltage. Yeah. Now let's see. What do we have here? We do have this in, right? Yeah. Pin number 17, but pin number 18 is the internal LDO output. So let's check this, the pin number 18. So this one is the input of the LDO, 13.4. Okay. And this one is the LDO, and we have 0 volts, 0.4. Let's check on the other board because I believe something here is wrong. Very wrong, actually. So on the spare board, we have pin number 17, we have 13.7, and here we have 5 volts. Check on the screen, LDO, 5 volts. So the LDO voltage here, the LDO voltage is missing from our board. And the question is, why? So this is our board from the laptop, and the LDO voltage is 0 volts. So the LDO voltage is missing. So what we are doing when the power rail is missing? What we are doing? Now 1 second. The input voltage is like 13 volts, but that doesn't matter. Doesn't change anything. Now it's 19. Yeah, it's okay. It was my fault. I set up 13 volts, but that's not a problem. Because even if we 19 volts, we still have here nothing, and here we have 18. Yeah. Good. So what I will do, I will come with the power supply like usual. We know the power rail has 5 volts, right? Good. Let's lower the current. Good. And let's come with 5 volts. Lol, but this probe is too big. Let me use a tweezer. So coming with 5 volts here, and it's taking 40 milliamps. Now, whatever is taking 40 milliamps is gone. I will take the thermal camera, because if we are seeing what is taking that 40 milliamps, that's the fault. It's fixed. Yeah. This chip cannot work without the internal LDO. Yeah, perfect. So I will come. Yeah, I have to keep the probe on the tweezer. I will come. Let me see. I will come here, and it's taking 40 milliamps. Check there what is getting. Check there. Check there. The chip. So the chip, it is faulty. I remember my was a long HP job, was like 1 hour, and I was spinning around this interseal chip, and uh, it was actually a capacitor on the LDO, was not a chip, and I replaced the chip, and it didn't work, and I found later on, after like 1 hour, wait, it was a capacitor on the LDO. Good. Replacing the chip, that should be an easy job. We can grab the chip from the other board. Let me isolate with Kapton tape. Good. And let's isolate that connector just to be sure. This one. I mean, we never know. Perfect. Now let's remove the chip first. 480 degrees. Perfect. So we remove the chip. The chip position. Yeah, we have that on the board. The chip position. Good. Now let's get the chip from the spare board, which is this one. Perfect. Let's move the chip here. Let's solder the chip. Come on, come on, come on. Good. Perfect. Good. Now let's solder. Perfect. The chip is soldered properly on place. Good. Now let's cool the motherboard with a little bit of thermal pad. Let's remove the Kapton tape. It will work. Good. Let's plug the charger. Plug. 1 second. Let me raise the current. The voltage, sorry. And the current. We need more current. So we need some current here. Good. Plug in the charger. 10 milliamps. Check that. 10 milliamps. Why do you think there is 10 milliamps? Because the chip, it is creating the main power rail. And the main power rail is, check on the screen, 12 volts. Why only 12? I don't know. It's a good question. But let's plug. We have the charging light here. Check that. Let me plug the battery and see if it's charging. I mean, that's the best test, right? So plug in the battery, plug in the charger, 10 milliamps, 40. Let's see if it's going up. It's not going up. $11.1. 300, 500, check there, 600, 800, 1 amp, 1.5, 1.8, Huh? Charging fine. So the battery voltage 12.1 and is going up. Check there. 79, 81, 84, 85, and so on. Is going up. So 1.8 amps. You see, this was a case where actually uh, the chip it was faulty. But it's not always like that. It's not always like that. And if you are an old subscriber, you know that. Okay, the SSD is back in place. Let's power on the laptop. We didn't reset the board. That's the reason why the board didn't start, probably. So pressing the power button and the laptop it is coming on. The current is going up. And yeah, it's working fine. Oh, not enough current. Not enough current. The power supply clicked. Did you hear the power supply? Yeah, analog power supply. And it's working fine. Fantastic. Let me shut down the laptop. Shut down. Just to be sure we are getting the charging current. Laptop is off. And we have 1.9 amps charging current. Yeah, it is off. Pretty cool. Yeah, I'm happy I helped him. Like I said, he's a nice guy, and I think he really loves HP laptops. I mean, it, he has a bunch of HP laptops, so yeah. Okay, I'm gonna stop now. I will say if you have this problem, it's a must to check. You have the LDO input, which is the main power rail, and you have a LDO output. The LDO input is coming from that resistor before the first MOSFET, and the LDO output has to be 5 volts. If VDT is pulled below 2.5 volts, reset all SM bus register values to default. But the problem was the chip was faulty. It's not like something dragged down that LDO voltage. The chip, it was faulty. So actually the LDO power supply from inside of the chip, it was faulty. So I'm gonna stop here. I will say thank you for watching. Like, subscribe if you like the video, and see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.